Hello, this is Sunita Varma, professor in the Computer Technology and Application Department, and I am here to talk about the introduction of compute. First, let us share the slide. So, with the help of that slide, we can further move in the lecture. Let us start with what is compute. If we talk about the computer is an electronic programmable machine that accepts the input that is in the form of raw data. That data is processed according to the instructions which we generally call the program, which is written by the user. These instructions are stored in the memory, and from the memory, these instructions are used for processing the data, and the final output is available to the user. For example, if we want to do the addition of two numbers, then we give two numbers as the input, then we write the instruction for adding these two numbers, and after this addition with the help of the instruction done by the computer, and the output is 4. Output of the addition is available on the monitor to the user. Now, computer is basically an electronics device because it is working with the electronic circuit and the electricity. So, electronic circuit user, there is a motherboard in the computer system. It contains different electronic components like diode, transistor, ICs, etc., resistance, inductors, etc. So, these are combiningly form the computer, the motherboard of the computer, hence it is a electronics device. They are programmable in nature, as I am telling you that when we are giving the instruction in the form of a program, the collections of instruction is called the program or the software. When it is those instructions are executed by the computer, it performs the task of the user. The computer performs 4 basic operations. It takes the data, which is called the input, it processes the data, it stores the data, and gives the output to the user. As one term comes when we are talking about the computer is data. So what is data? Data is commonly a raw data, and it is the collection of text, number, symbol, etc., with whom there is no context or no context is associated, so there is no meaning of that data. And so to add the context with the data, it is required to process the data so it becomes meaningful. So to understand the concept of data, let us see the examples. The examples are, suppose there is a series of number 3, 6, 9, 12, or there is a name of the animals, cat, dog, greybill, rabbit, coquetto, or there are certain floating point numbers are there. So we cannot interpret anything. They are just number, or they are just the name of the element. They are just the name, but there is no meaning associated with this set of numbers or the names. So they are called the data. We cannot say anything about 3, 6, 9, or 12, or why these names of the animals are written, why these fractional numbers are used. Data become useful when after processing the data is converted into the information, and finally the information is converted into the knowledge. The term related to the data is information. What is information? When we process the data, as I am telling you that when two numbers are given, there is no use of those two numbers. But when we add this two number, it gives the result. So now we know the context. Context is we are doing the addition of two numbers. So what is the purpose of this two number? On adding this two number, we are getting certain output. So information is the processed data. When we are processing the data, the context is associated. Context means the meaning is associated with that data, and it is called the information. When we are talking about the information, the raw data is processed, and that raw data is arranged, is processed or arranged in some meaningful output, then it is called the information. For example, we have seen that there is a series of number 3, 6, 9, and 12, or these are the names of the element. But if we say that 3, 6, 9, and 12, they are the first four numbers of the table of 3, then there is a context associated with this number, and it is showing that they are multiples of 3 and they are representing the table of 3. If you are saying that the name of the animals are the household pets, then it become meaningful. These names of the element are the name of the elements which are the pets. Or if we are saying that these fractional numbers are showing the heights of the 15-year-old student. So now the context is associated. For example, they are the multiples of 3. They are representing the table. So it becomes useful for the user. Or if we are saying that these are the names of the household pets, then it is again giving certain information. These are the names of the animals who are the household pets. Or these are the height, means some students are there whose heights are these numbers. So now we can, having the usefulness of this series of number or these names of the element, when we add the context with this data. Now, the another term is knowledge. When the information is memorized, it becomes knowledge, or it becomes the learning to the user. So if we learn the table of 3 and we memorize it, then it becomes the knowledge for us. Because if somebody is asking me what is 3 into 3, then we automatically say 9. So it is our knowledge. So when we memorize the information, it becomes the knowledge for the user. Or the another form of the knowledge is produced by understanding the information. And when we understand this information, the understanding of the information can be used to solve other problems, so that we can also call the knowledge. See the equation. When information plus application or use of the information is there, it is called knowledge. This example, we can see how data, information, and knowledge are related. If we say 4 into 8 in 4, 8, 12, and 16, they are the first four answers of the table of 4 that we can derive from our knowledge. What is our knowledge? Our knowledge is that the table of 3 start with 3. When it is multiplied by 2, it becomes 6. So we can say that if the number is starting with 4, when we multiplied it by 2, it becomes 8. So it becomes the table of 4. So if we know the table of 3, and if we apply our knowledge, then we can derive the table of 4 also. That is, start the table of 4 with 4 and then multiply with 2, 3, etc. So we can, by memorizing the table of 3, it becomes our knowledge, and we can use that knowledge to derive further more information or to solve the problem. If we know that this is the information for showing the height of the student, then we apply our this if we memorize, then we can apply our knowledge. Then we can say that the tallest student in this if this is the height that we know, then we can apply the knowledge. The tallest student is 175.3 centimeter. So information, when we memorize, it becomes the knowledge, and we can solve many problems. Suppose the names of the animals are there, and we say that these are the names of the pet elements. Then somebody told me lion, the word lion. Then we can apply our knowledge and can say that this is not the pet element, because we remember the name of the pet animals. So it is not the pet element. That knowledge we can apply. After seeing this basic concept of data, information, and knowledge, we further talk about the basic organization of computer. So, as I told you, it is an electronics device and it performs 5 major different types of the operation. Computer accept the data or instructions which are the input for the data. Whatever the data and instructions are given to the computer, they are first stored by the computer, and after storing the instructions and data, the computer processes the data with the help of the instructions, and after processing the data, it displays the result on the output device, or it will give the output to the user. And for performing all these operations, some coordination on or control operation is required, and that coordination and control operation is also performed by the computer. So in all, 5 operations are performed by computer: accepting data and instruction, then it stores the data and instruction, process that data, display the result as the output, and perform all these 4 operations. For performing all these 4 operations properly, the control and coordination is done by the computer. This is the basic block diagram of the computer. So the first unit is the input unit, as we talked about. Input is given to the computer. So input is there from where the data and instructions are given to the computer. Now this input is stored in the storage device. From the storage device, it may go to the central processing unit. Central processing unit consists of control unit and arithmetic and logic unit. The data is processed in the control and arithmetic and logic unit, and it is displayed on the out as the output. And control unit, as I am telling you, that all operations are to be performed in sequence and in proper order. It is controlled by the computer system, and that unit is the control unit. As I'm telling you, that input is given to the computer for entering the data or for giving the instructions to the computer. So this input is given to the computer by using the input devices. Examples of the input devices are keyboard, mouse, microphone, scanners. These are some of the examples of the input device which are used for giving the input to the computer. For example, from the keyboard, we can enter the data, we can enter the instruction. By using the click of the mouse, you can give different input in the form of performing the operation. From the microphone, we can give the voice instructions to the computer, and from the scanner, we can give the scan copy of the information to the computer without typing it. And this information which is given from the input device is processed by the computer. Computer only understand the binary language and binary language means only represented by using 2 digits, 0 and 1. So why computer is working only on binary digit? Because computer consists of electronic devices, and electronics devices are having only 2 states, either on or off. So one state is represented by 0, another state is represented by 1. So it can understand, the computer can understand only 0 and 1. When we are using the input device, the information is given in the form of the language which is understood by user. So it is given in the form of alphabets, or by using the numerals, etc., which are numerals are the decimal numbers. They are not understood by the computer. So one of the responsibility of the input device is to convert this data which is given by the user into the binary language, which is also called the machine language. Storage. When we give the input to the computer, it goes to the storage of the computer. Why it is necessary to store the data in the storage of the computer? It is necessary to store the data into storage of the computer for many purposes. So to understand the different purposes, let us take the analogy of the human. So when some information is given to us, some data is given to us. Suppose I am saying that the table of 3, 6, 9, etc. Now we can use this information if we memorize it. If we are not remembering that information, there is no use of that information. And this, we can apply the knowledge if we are remembering the information. And for example, if you want to find out the addition of three numbers, so what we are doing, first we are adding the two numbers, and whatever the intermediate result is there, first store that result and then use that result for performing the addition of the third number. So for memorizing the input, for memorizing the instructions, and for memorizing the intermediate, for storing the intermediate data, the memory is required or the storage is required. The another use is, for example, computer, there is a single processor. So all the instructions and all the data is not executed simultaneously. The instructions and data are executed one by one, and the data is processed in intermediate state. So if we are not storing the instruction, then if we are giving a set of instructions to the computer in the form of a program, so it is essential to store all those instructions. Instructions are not executed simultaneously, they are executed in sequence. So somewhere they should be stored. So sequentially, the CPU accesses those instructions and can process the data. So there is a need of a storage in the computer system. There are two types of the storage system in the computer system: primary storage and the secondary storage. Primary storage, commonly called the main memory of the computer, and the central processing unit access the data and the instruction only from the main memory. The examples of the main memory are random access memory, cache memory. They are very fast, but the problem is that they are very volatile in nature. What is the meaning of volatility of the main memory? The data stored remain in the main memory till the power is there in the computer system. As soon as we shut off the power from the computer system, whatever stored in the main memory is lost. So when you restart the computer and you want to use your data or previous instructions or program, they are not available. You are required to re-enter that data or the program. And they are very fast because CPU is working at a very fast speed. So semiconductor memories are used, they are fast. So computer can access the data and the instruction with the faster speed. But because they are consisting of the semiconductor material, to getting the fast speed of access, they are costly. Main memory are relatively costly. So there is a need of a secondary storage, because once suppose we write a program of 1000 line and there is a data of 1000 number. So if you store it into the main memory and switch off your computer, then all the things are lost, and again re-entering 1000 line and data of 1000 number, it is a tedious task. So a memory is required which can permanently store your data, and that is done by the secondary storage. Examples are hard disk, solid state drives, SSD you heard about, optical disk, pen drive, etc. They are the secondary storage, because first the data comes into the main memory and then it is stored into the secondary storage. And the speed of because they are the electromechanical device, so they are slow. So if computer is directly accessing the data from the secondary storage, the speed with which the data is accessed from the secondary storage is little bit slow. So the CPU cannot execute with its full capacity. It remains in the waiting state. So to continuously the data and the instruction to be executed by the CPU, it is first copied into the main memory, which is very fast. So the CPU always access the data from the main memory to match its speed of execution and the access of the memory. So data is permanently, it is the secondary storage is not volatile. The data is stored permanently, whether you switch off the computer or your computer is not working, still the data is there. Whenever you again switch on your computer, your data is available in the hard disk or SSD or on the CD or on the pen drive. You can access the data, which again copied into the memory, computer perform their task and permanently store it into the secondary storage. Third type of the storages, which is nowadays very popular, is the territory or the cloud storage. And cloud storage, for example, you are using Google Drive, you are using Microsoft OneDrive, etc. They or magnetic tapes are there. They are used for archiving your data, because when the data is collected, or now the applications are such that social media applications or e-commerce website, they are generating very large amount of data. So the hard disk or SSDs are not providing that sufficient space. So if your data is in the range of petabyte or zettabyte, it is required to archive. So it is required to take the backup or archive that data, and that is generally done in the cloud storage, because they are providing the user the unlimited amount of storage. The another unit we had seen is the central processing unit. Like the human brain, it is the brain of the computer. Central processing unit, as we had seen, that it consists of two parts, the arithmetic logic unit and the control unit. Arithmetic logic unit is used for performing two types of operations, the arithmetic operations or the mathematical operations and the logical operations. So if you talk about the arithmetic or the mathematical operations, they are the addition, subtraction, multiplication and division. Multiplication and divisions are also implemented by using the concept of addition and subtraction in computer. And if you talk about the logical operation, they are the comparison or the decision making. For example, we are comparing 9 is greater than 3 or 3 is less than 9. So these are basically the comparison. And output of the comparison, if 3 is smaller than 9, then say hello. So we can make the decision based on the comparison. So many relational operators are available, like greater than, less than, greater than, equal to, less than, equal to, not equal to, etc. So these are used for doing the comparisons, and by doing the comparison, it helps the user in making the decisions. The another unit is the control unit, and control unit is used for controlling the different operation and syncing the different operation of the computer. For example, if you are giving the input, it first goes to the storage instead of going to the arithmetic and logic unit. So this is controlled by this flow is controlled by the control unit. So control unit controls that the data of the input goes to the storage. Then if it is required to fetch the data, so when to fetch the data, it is controlled by the control unit. After fetching the data, it decide whether it goes to the arithmetic or logic unit. It goes to the arithmetic unit or logic unit. When it goes to the output, when the data, so all the operations are synced and controlled by the control processing unit of the CPU. One more component of the CPU is there, which is called the registers. They are very small memory which is available on the CPU. So they are the fastest memory with which the computer can work. So to store the temporary data, the registers are used, so it is possible for the computer to perform the operations with a good speed. Output. Output refers to display the result of the processed data, and this is done by the output device. So output devices are, for example, you can use the monitor, printer, or Many examples are there. Those examples are used for giving the output of the computer. So commonly used outputs are the monitor of the computer, the printer. Printer gives the hard copy of your result while the monitor shows a soft copy. That is, the result is available till your computer is on. So after processing of the data, after generating the result goes to the storage, and from the storage it goes to the output device. And we can use speaker also as the output device because it is generating the audio or audio information, or we can see the image, or we can see the text. These are the form of the output which can be seen by the user. So monitor, printer, speaker, projector, these are all the examples of output device. They are used for seeing the output of the processed data by the user. Processing. Processing refers to the stage where the data received from the input device are worked by the central processing unit and converted into the useful information, which is the result of the processed data. So we had seen that when we process the data, it becomes the information, but how this is possible, how the data is converted into the information, that is possible by processing the data. How the data is processed? The data is processed by giving the instructions to the computer. So if you are writing a program of finding out the maximum of 3 numbers out of given 3 numbers from the input device, then you write the program in any of the higher level language, and the computer, with the help of that program, find out what is the largest element number out of these 3 numbers, and that is the information for us. If 296 is the 3 numbers, then 9 is the largest number. So that is the information for us out of these 3 numbers, what it is showing. If we want to find out what is the largest number, we can find out by adding the context to that data. So that is done by processing. Processing means instructions are given to the computer with the help of the programs. They perform the necessary task desired by the user, that is called the processing, and get the meaningful result from the raw data. When we are giving raw data as an input, the CPU interpret the data, interpret the instructions given by the user, and accordingly perform the calculations or processing that data, organize that data, and give the output to the user. So this is all about from my lecture. Thank you. Thank you all for patience. Yes, thank you.